All right, so this is going to be the key here. Different classes got different bonuses, but this particular bonus, the answer was B, USS Texas. I believe I gave this particular class test 2, period 2, or slot 2, I guess, really, right? I don't remember when it was during the day. All right, so anyway, spitting cobras can defend themselves by squeezing muscles around their venom glands to squirt venom at an attacker. Suppose a spitting cobra rears up to a height of 0.480 meters. Okay, so I don't know what a spitting cobra looks like. Maybe they got 2 fangs. And this thing has a height of, zoom in, 0.480 meters. Okay, above the ground, and launches venom at 2.50 meters per second, 55 degrees above the horizon. Okay, so here we go. That's the horizon more or less. Here's our 55 degrees above the horizon. And what was the speed? 2.50 meters per second. 2.50 meters per second. Okay, draw a picture. Oh, good, I already did that. Label everything you know and are looking for all the parts below. Okay, so let's see. So this thing is going to go like cruise like this, and it's going to hit the ground. Okay, so here's the ground. Okay, or something like that, right? This little bit is not necessary. Okay, cool. All right, so I'm not going to fill this out until I know what I'm solving for. So let's see, what are we solving for? How long does the venom take to hit the ground? So that means we want to know the time right here. I don't know if that's T1 or T2. We'll figure that out. I know that this right here, where it starts, that's T0, right? I think we can all agree that that's going to be when this problem begins. Okay, what is the speed of the venom when it hits the ground? Okay, so that means we want to know the speed right here. So V equals question mark. Again, I don't know if that's 1 or 2. I guess it depends. We'll find that out in a second. How far away horizontally does the venom hit the ground? So that means we want to know this distance right here. So that could either be X or that could be delta X, right? I think it's going to be delta X. Oh, well, let's erase this. All right, we're basically saying how far away does it, from where it begins, right? So anyway, I don't know if that's X2 or X1. I guess it depends on if they ask us anything about the maximum height of this thing. Okay, so, and then the last thing is your eyes are 1.65 meters above the ground. Are your eyes safe from the cobra shot? So what we're asking is, does it ever get to 1.65 in height? So what we're looking for there is we're looking for this height right here. Okay, so I'll call that Y. Okay, and if that's everything that we're asking for, I'm going to call this position 1, so that's going to be a question mark. So there's a T1 right there, but I'm not really worried about that time. It didn't ask me. I guess if I need it to get Y1, then I will use it. All of these other things, these are at location 2. All right, so let's start with the initial stuff. Okay, for the entire problem, A and the X is 0, and the Y is negative 9.81 meters per second squared. Okay, so for X naught and Y naught, so T0 equals 0 seconds. X naught is going to be this position right here, which I'm going to decide that that's 0. I'm going to decide Y naught is 0.480 meters. It doesn't have to be 0.48 meters. It could be 0 if you prefer that. The problem is if this is 0.480, if this is 0, then your Y2 right over here needs to be negative 0.480. I prefer my Y2 when it lands there to be 0, right? Because it's landing at the ground level. So what I've kind of decided is that this point right here is going to be 0, 0. Okay. All right. Let's see, what else do we have? Oh, we need V naught in the X and V naught in the Y, so we'll zoom in on there. So V naught in the X and V naught in the Y. I'll do this in red, because here's my V naught in the X. Here's my V naught in the Y. So V naught in the X is going to be 2.50 cosine of 55, because it's adjacent to that 55. And the vertical is going to be 2.50 sine of 55 degrees. Okay, so if I use my trusty dusty calculator, and I will use my trusty dusty calculator, this is 1.4, I don't know why I changed colors there, but I did, meters per second in the X direction. And the Y direction, this is 479. Okay. 0.479 meters per second. Notice we're going to, everything in this problem has 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. So we're going to keep 5 throughout the problem so that we won't have any rounding errors. Okay, cool. All right, sweet. Okay, so let's put those numbers in down here. So V naught in the X is, let's go back to black. 1 point, wasn't that is that a Rolling Stone album's Back to Black? It's probably AC/DC. I hate AC/DC. 2.04. It's not that they're so bad. It's just they made the same song 30 times and they just keep putting it out and then everybody kept buying it. All right, so those are our initial conditions. Okay, now we want to know, we need to get information up here at position 1 or at T1. And we're looking for Y1, right? So Y1 means we're looking for this, right? I don't know what X1 is, so I'll leave that blank. I don't know what the time is, so we'll leave that blank. I don't know what that is. I do know that the velocity in the X direction is 1.4339 meters per second, and I know that because the acceleration in X is 0. Oh, that should be an X. Okay, and then the key to solving this is that we know that when the projectile is at its highest location, we know that the velocity is only in the X direction, so the velocity in the Y is 0. Okay, so that's the key to solving this. If you did not get that, you probably are not going to be able to solve this part. Okay, so that's to solve for the highest point, and that I think is part D. I didn't give you letters, but the fourth part of this problem. Okay, for these others, X2, T2, and V2. Okay, so we're looking for this time. Okay, and we're not really looking for this quantity or that quantity. We're going to combine them together to get the velocity on an angle, or the speed, right? Okay, so we are looking for X2. We do want to know where it's going to land. So those are our 3 things that we're looking for: T1, X2, and the final velocity. We don't know this particular quantity right here, but we will need it in order to get this. Okay, now V2x, in the gift that keeps on giving, we know it's going to be 1.4339, right? Because the velocity in the X is constant. There's no acceleration in the X. Okay, so we're going to begin. How long does it take for the venom to hit the ground? Now, so that is asking at position 2. So that is right over here at position 2. Okay, so one of the things to note, okay, so usually in these problems, right, if it's asking for time, especially if it asks for time first, remember, there's always the possibility that we can end up with a quadratic, okay, and that can happen, and we would like to avoid playing with the quadratic if we can avoid it. The nice thing is that if you want to avoid the quadratic and it's asking for the velocity, then Vy is the first step, because that will help us get it time without having to do a quadratic. Okay, so let's go ahead and get Vy. Let's go ahead and get V2y first. Okay, so to get V2y first, this is the key right here. Okay, so I don't have time. So remember, if you don't have time, then almost always the equation you're going to want to use is Vy squared equals oh, son of a monkey's uncle, equals V naught in the Y squared plus 2ay delta y. Almost always, because we don't have time, so this is what we're going to want to use. So V in the Y equals the square root of V naught in the Y squared plus 2ay delta y. Okay, it is customary to put a positive or negative right there. I'm going to go ahead and note the fact that at the end of this problem, I know it's going down because it's going to the ground, so I'm just going to leave a negative right there. Okay, so Vy equals negative square root. V naught in the Y was 2.0479 meters per second squared plus 2 times negative 9.81 meters per second squared times delta y. The delta y, okay, note this is 0.480. This is 0, so I went down 0.480. So negative 0.480 meters. Okay, so if I plug that into my calculator, my Vy is going to be negative 3.6894 meters per second. Okay, so that is my vertical velocity when it hits the ground. Okay, I'm not worried about putting that in, you know, this is not something we're solving for, so I'm not going to bother rounding it just yet. Okay, so now we're going to go get time. So if you have the vertical velocity, right, that getting the time comes out of this equation every time. Well, I say every time, and it makes me nervous. Just about every time. Okay, sorry. This is usually, I've been writing this as V naught in the Y. Voy plus AY times T. Okay, so if I rearrange that, then I can say T, this is T2, right? So this is VY2. T2 equals VY2 minus VY, well, V2Y, I think. Yeah, V2Y is how I've been writing this. Let's go ahead and okay, divided by AY. Always be especially careful about the signs when you're subtracting things. Okay, so V2Y is that number right there. Oh, well, I should have put a 2 on all of this, shouldn't I have? Okay, that's because that's at 0.2. Okay, V2Y is negative 3.6894 meters per second minus the initial velocity, which was a positive 2.0479 meters per second, negative 9.81 meters per second squared. Okay, so T2 then equals, so the time at position 2, 0.58484 seconds. Okay, so because I care about this answer, we will go ahead and do the sig figs. We will bring this back to 3 sig figs. And this will be 0.585 seconds. Booyah. Okay, nailed. All right. What is the speed of the venom when it hits the ground? Well, this is like this is a clean problem right here. Okay, so I know it's going to the right. How fast is it going to the right? When it hits the ground, it's going at that speed, 1.4339 meters per second. Okay, in the y direction, it's doing that, so it's going down at 3.6894 meters per second. So we just need to get the diagonal in this one. Okay, and I didn't ask for the angle, but I could have. And so what we'll do is we'll say that the speed is the square root of the Vx squared plus Vy squared. Now this is at 0.2, this is at 0.2, this is the speed at 2. Okay, so V2 equals the square root of 1.4339 meters per second squared plus 3.6894 meters per second squared. Okay, and V2, if we plug all that in, we get 3.9582 meters per second, or V2 equals 3.96 meters per second. It should be positive because this is a speed, right? If I'd wanted the velocity, I would say V2 equals 3.96, and I would have given it an angle, right? And I would have done that angle as being the inverse tangent of the x over the y of 3.6894 meters per second divided by 1.4339 meters per second. Okay, note, I did not ask for this, so you don't need to do this. Okay, this is not necessary. In fact, if I asked for the speed and you gave me the velocity instead, that you would lose a point. So just be careful that you think about what's being asked in that particular problem. All right, cool. So how far away horizontally does the venom hit the ground? Okay, so how far away horizontally? Okay, so if we're asking for how far away horizontally, and we know that we are, and we know that we have time when it hits the ground, so I can say delta x at position 2 equals v naught in the x times t at t2 plus 1/2 ax t2 squared. The nice thing about this one is this goes away because ax is 0. Okay, technically this could be expanded into x2 minus x0 because note this time is from 0 to 2. However, we don't really need to bother with that because x0 is 0, right? That's the beauty of saying I want to start at position 0. Okay, so v naught in the x, what's v naught in the x? It's the same thing for this whole problem. right? So V0 on the X is right here, 1.4339. 1.4339 meters per second. And then the time, where do we get the time? It's right here, 0.58484. 0.58484 seconds. Okay, so when I plug that into my calculator, I get this nasty number, 83860 meters. Okay, and because I care about this answer, we will do sig figs and we'll do 0.839 meters. Okay, cool. Okay, moving on. So we want to know how high this shot gets. All right, so I'm looking for this max height. Okay, at this position, I'm looking here for the max height period, and I'm trying to compare it against the 1.65. Basically, I'm asking, is this 1.65 meters, is that above or below this point right here? Okay, now I want to note that when I'm doing this, it's this time, I don't have this time, but I want this y. Okay, so this is pretty clean. When you don't have time and you don't feel like solving for it, right? We have an equation that is like designed for that. Okay, and that equation is this one. Vy1, because we're at position 1, squared, equals Vy naught squared plus 2ay delta y. Okay, now this delta y is from 0 to 1. Okay, so just be aware of that, all right? The key here is to know, as I mentioned earlier, that Vy1 is 0. Meters per second. Sorry, I got my units wrong here, didn't I? When I put it in there. I'm not going to go back and remake the whole video for that. 0 meters per second. Okay, so at its peak, it is no longer going up, it is no longer going down. So that is how we're going to solve this particular problem. Okay, so if we go down here we go. At its peak, this guy is going to go away. Okay, so let's go ahead and solve this. We'll go delta y from 0 to 1. Equals, let's see here, Vy1 squared minus Vy naught squared divided by 2ay. Okay, so delta y 0 to 1 is 0 squared minus, in parentheses, 2.0479 meters per second. That's the initial velocity in the y, squared divided by 2 times negative 9.81 meters per second squared. So delta y from 0 to 1 is 0.21376 meters. Okay, so that's cool and everything. However, that tells us how much it rises. It does not include the bit where it started. So we're going to expand this into y0 minus y naught, 0.21376 meters. Okay, noting that this sucker started at y1 equals, let's just go ahead and put minus, what was the initial height? 0.480 meters, 0.21376 meters. Okay, so y1, its max height here is 0.69376 meters. Okay, I don't care about this specific number, so we don't really have to do the sig figs here, but we can. But the key here is that this number is significantly less than the 1.65 meters you are tall, so you're completely safe. Okay, so that's test 1. Okay, I would imagine nothing too shocking. Okay, let's go down to test 2. This one, it appears, was taken by slot 6. The bonus for that one was y, and the answer was y naught. Okay, so we will do this as a key. Okay, let's see here. A projectile is launched from, I think this is essentially the same problem, just with different numbers. And instead of being a cobra, it's a cliff. Okay, so a projectile is launched from a cliff 100 meters above ground level with a launch velocity of 30 at angle 22.2. So we're going to have 3 sig figs. So we're going to use 5 throughout. Okay, so that's good. All right, let's see here. So we want to draw a picture. Let's draw a picture. Here's our cliff. Okay, this cliff is 100 meters above the ground, right? Okay, launch velocity of 30 at an angle of 22.2 degrees. Okay, son of a, okay. So that's all the cliff. Okay, so we're going like this. 30.0 meters per second. We've got an angle here with the horizontal, 22.2 degrees. Okay, it's gonna go like that. It's gonna hit the ground somewhere over here. Okay, cool. All right, let's go ahead and let's do our initial stuff here. So this should have been AX. So we'll say 0 meters per second. This is gonna be negative 9.81 meters per second squared. Let's get our initial stuff. The first thing I'm gonna do is I'm gonna decide that my origin is gonna be right there, 0, 0. Okay, so A and the X. Sorry, X naught. So it's gonna, the whole problem is gonna begin right here. So the initial velocity, the initial position in the X is 0 meters and the Y is 100 meters. Okay, the initial velocity in the X and in the Y. Let's zoom in right here. I think last time I did red, we'll go ahead and do red again. So that's the, adjacent side. So this will be 30 cosine, because it's the adjacent, 22.2, and this will be 30 sine of 22.2. Okay, so let's see, 30 cosine 22.2 is going to be 27.776 meters per second. And this vertical one's going to be 11.335 meters per second. Remember, we're using 5 sig figs throughout this problem. Okay, so let's go ahead and fill those in down here. V naught in the X and V naught in the Y. Okay, in the X direction, we've got 27.776 meters per second. And in the Y direction, 0.335 meters per second. Okay, we're going to use this gift which keeps giving, and I'm just going to go ahead and fill this out everywhere. It is the gift that keeps on giving. Cool. All right, before I even know what Y1 and Y2 are, as long as it's during the projectile's motion while it's still in the air, those numbers are going to be the same. Okay, cool. Now let's see what we're asking. Okay, calculate the maximum height above ground level that the projectile reaches. Okay, so we're going to calculate right here. I'm going to want to know this. Okay, I'm going to know Y equals what? I'm assuming that's going to be Y1, because this right here, this is T0, so that is probably T1. But let's go ahead and we'll see what else they're asking. Determine how far away from its launch point horizontally the projectile lands. So we want to know this distance right here. Okay, X equals what? That could be X or delta X. Since I decided that this thing is starting at 0, those will be the same. I'm assuming that's going to be position 2, but we will figure that out in a second. How long does it take the projectile to hit the ground? So we want to know the time. Okay, so we want to know this. We want to know T equals question mark. Okay, so X and T are at the same, are in reference to the same point. And if it's normal, I will ask for the speed. Oh yeah, how fast is the projectile moving when it hits the ground? Okay, so when it hits the ground, I want to know the velocity or the speed on this angle. So V equals question mark. Okay, that said, this right here, this point right here, this is going to be T1. Oh wait, we're not necessarily solving for T1, but we'll just call that T1. Okay, this would be Y1. Y1 is one of the things we're looking for. Okay, all of these things which refer to this point down here, this is going to be T2, V2, and X2. Okay, so let's see. Let's fill those question marks in. Y1 is a question mark. Let's see, Y1, we're looking for something right there. Now I will note that we don't know the time. Oh, we know this is 0 seconds. We don't know the X. We only know that at the top of its velocity, right up here, that it's cruising horizontally. It's not going up or down. Okay, so V1Y is 0 meters per second. It's not going up or down. That's the key to solving this problem, right? You need this piece of information. Okay, when we consider this position 2 down here, let's see here, X2, well, that's one of the things we're looking for. The time is one of the things we're looking for. And we are looking for this speed. Now the speed is on an angle, right? So v equals question mark. Okay, in order to get that, I need to solve for this. I don't actually, I'm not actually solving for that. Like I don't care about it, so I don't need to like round it or anything. Maybe I'll put that in blue, right? That's an intermediate step. The last thing is at this point right here, I do know that elevation, right? It's at the same elevation that this thing started, so it's going to be at y2 is going to be 0 meters. Okay, so let's calculate the maximum height above ground that the projectile reaches. So I'm starting here. Okay, y1 equals what? Okay, the key to that is this particular piece of information right here and the fact that we don't know the time. So if we don't know the time, your gut should, you should be getting pretty good at this. Your gut should say, okay, well, I want Vy, okay, Vy1, or V1y, I guess is how I've been doing this. V1 squared equals V naught y squared, right? We do the squared equation if we do not know the time, plus 2ay delta y. Okay, so I will rearrange that and I'll say, well, ooh, delta y equals v1y squared minus v naught y squared divided by 2ay. Okay, delta y equals, okay, so remember at the top, the final velocity is 0 meters per second, 0 meters per second squared minus the initial velocity in the y, which is right here, 11.335 meters per second. And then we're going to divide that by 2 times negative 9.81 meters per second squared. Okay, if I solve for this, delta y equals, I guess I should remember that this is delta y from 0 to 1, 0 to 1, 0 to 1, 0 to 1. Anyway, the calculator will tell you that this is 6.54, excuse me. 5488 meters per second. Okay, and if I wanted to be clear about that, I could say, okay, well, a lot of you would just say, oh, that means it went up 6.5488 and it started at 100. So it ends up going at 106.5488. Oh, I got my units wrong, didn't I? The formal way to do this is that delta y is y1 minus y0 equals 6.5488 meters, and y1 minus 100 meters equals 6.5488 meters. Okay, so y1 equals 106.5488 meters. Okay, and that is a horrific number, and with sig figs, we were going to go to 107 meters. Cool. All right, cool. So that is, we are now done with this particular point because we know everything that we want to know right there. So let's go down to this point right here. Remember, the quickest thing is if we get time, everything else becomes easy. However, again, just like in the last one, if we get the v in the y direction first, then we don't have to do a quadratic equation. So determine how far away from the launch point the projectile lands. Okay, I'm going to go out of order here. I don't want to do that. Let's get time first. Determine how long after launch does it take for the projectile to hit the ground. So this is where we're going to solve for time. But as I say, like I don't want to do the quadratic equation. So I'm going to figure out the speed first. Okay. So to do that, I need to get v in the y. Okay, v2 in the y. Now remember, if I don't have time and I want a velocity, it's always going to be easiest to do this. V naught y squared plus 2a delta y. This is going to be from 0 to 2, right? Delta y is from 0 to 2 because my velocity is from 0 to 2. Okay? So my initial velocity in the y, well, let's see, what do we solve? Oh, v2y. So v2y equals the square root of v naught y squared plus 2a sub y delta y o to 2. Okay, I'm going to put the negative sign here because I know that it's not going to be moving upwards at that point. Okay, so v2y equals negative square root. So the initial velocity in the y, if we go all the way up, it's right here, 11.335. 11.335 meters per second squared plus 2 times negative 9.81 meters per second squared. Okay, and then the delta y from 0 to 2. Okay, I can look at my picture and I can just say, oh, look, I started here and I went down 100. Or I can go over here and I can say, okay, well, I started at 100 and ended at 0, so I went down 100. So that's negative 100. Okay, so I'm going to go ahead and put in negative 100 meters. Okay, and V2y equals, what do we get here? Negative 45.772 meters per second. Okay, again, we don't care about that, so we're not going to worry about sig figs just yet. But now that I've got that speed, I can get the time, or that vertical velocity, I can get the time. So here's the time. Okay, so let's see here. To get the time, it's almost always, it's the same equation over and over again. V2y equals V naught y plus 2a, not 2, just a single one, ay times t. Okay, and that t is going to go from 0 to 2. Okay, so if I rearrange this, t from 0 to 2 equals, let's see here, v2y minus v naught y divided by ay. So TO2 equals this v2y. Let's see, we just solved for that down here. Negative 45.772. Negative 45.772 meters per second minus the initial velocity, which was a positive 11.335 meters per second. Okay, the acceleration to y is negative 9.81 meters per second squared. So TO2 is, let's see here, 5.8162 seconds. Because this is a question that I actually asked, like it's asking how long after the launch, we can say TO2 is 5.82 seconds. Okay, be very careful. We're going to use this one. However, we're going to report this one, right? We report with 3 sig figs. We're going to use 5. We're going to use 2 extra. All right, so now we've got time. So determine how far away from the launch point the projectile lands. Okay, so delta x, okay, from 0 to 2 is v naught in the x times time from 0 to 2 plus 1/2 a in the x t in 0 to 2 squared. Okay, again, as always, this thing goes away because ax equals 0. So we love that. Okay, so delta x from 0 to 2 equals, let's see, v naught in the x. What's v naught in the x? Let's see. Oh, there it is. Look. V naught in the x, it's constant, so we can just use it. Okay, 27.776 meters per second. We'll multiply by that time that we just solved. What was that? 5.8162. 5.8162 seconds. Delta x2 equals, if we multiply those, what are we going to get, like 150 or something? What does it say? 161.55 meters. And since I care about this number, we will report it as 162 meters, 3 sig figs. Booyah. Okay, good. So we've got this part answered. How long after launch? We've got that answered. How fast is it going when it hits the ground? Okay, so I got this number. And note, we know that V2 in the x is that same number, 27.776 meters per second. Okay, so we can take these two and we can make a triangle. Okay, so this is going to be 27.776 meters per second. And then we're going to go down in the y, 45.772 meters per second. Okay, so there's my triangle. So v at 2 is going to be the square root of v2x squared, v2x squared, plus v2y squared. Okay, so v2 equals, let's see, 27.776 meters per second squared plus 45.772 meters per second squared, square root So V2 equals, if we do that square root, 53.498 meters per second. And we care about this number, so we will go ahead and significant figurize it. So 53.5 meters per second. Boom. Okay, that one was a little faster than the last one, but whatever. Okay, so there you go. That's your test. This hopefully will help you to understand what you did wrong, what you did right, all that stuff. Okay, so study hard, take care. You are important. Remember that, okay? And that means all of you, not just your academic self. All right, so hopefully this was helpful. Take it easy. All right.